Okay. So today is date 8 and 176 test left. So yesterday I forgot to share one thing. The exam result. I got around yeah, supposed to make I got around 12 marks out of 15. Okay. I had done three mistakes. But on those three mistakes, two are very silly mistakes and one is conceptual mistake. Okay, fine. I got that. Yeah, I can see here. And yeah, you can see here this question is conceptual mistake. This question is also, and these questions are wrong. It means I learned a concept. Okay. Now today we'll write one more test. Okay. I have studied data structure related to binary. I mean, related to binary search trees. We'll write one test on PYQs. So let me choose the test. Yesterday the live was ended because of internet issue. Think today is it okay? I think it's okay. Yeah, I think so. Okay. Okay, anyways. Binary search. There are total 36 questions on binary search tree on PYQs. And then binary tree, there are totally 53 questions. I think these two are excluded. Okay, let me try first test of 15 questions. Okay, let's try this test. Okay, we have one question very hard. Accuracy is zero. There are total only 11 takers are there. Okay, what? They got so less marks. I think this test is quite interesting. Okay, let me try. Binary search tree. Okay, total and yes. Data structure. Okay, let me. Okay, still let trying. Should I think my sound audible or it's overflowing? Test this. Yeah. Think today is it okay? I think it's okay. Yeah, I think so. Okay. Okay, anyways. Yeah, everything perfect. Okay, I'm going to start the test. Oh, okay, 27 minutes, 15 questions. 15 minutes each means each question we did get even 1.5 minute. Okay, but where such tree contains values 1, 2, 3, and 8, the tree travels in pre-order. The values are printed out. So the following sequence is value output. Okay, binary tree. The values are the trees. Okay, they are not mentioned any values, so just take like 1, 2, 3, 4, 5, 7. Okay. The trees travels pre-order. Okay, pre-order. Pre-order means root, left, and right. Okay, fine. So the values are printed out, which are the following sequences, valid output. Okay. So these just are elements in the tree, but it's not the order. Saying tree is printed out. Okay, following sequence. Okay, valid. Okay, they are given root as 5. Okay, I mean they are not given by options. We can say root as 5. Okay, root as 5, and then left and right. So the pre-order left and right. Okay, if we assume as root as 5, so okay, we can't say the elements right. It's like maybe it may not be okay. If we take left, this binary search, it means left should be less than 5. Okay, left is 3. Okay, 5 and 3. Okay, left. And then 1. Okay, and then 3. Then, and then after it will not become red, right? So, okay, 3. Wait, now came up with this type of questions. There's root left and right. Okay. The left is 3. The right must be greater than 5. Okay, right must be greater than 5. Okay, let us see. Okay. Okay. Option B is definitely false. Option B is definitely false. Left with option A and D. Option B also I think false. And this question is this much. Three travels from Theodore and values of 22 to keep from as output. Think option the leftmost value should be highest, which could be like 8. I think if we consider 8, left it 20. And I think 3, 2, 1. I think option D will be the correct answer. Yes, I'm just guessing. I mean, it's not guess. It's a conceptual guess. Okay, let's. Number of ways in which the numbers 1, 2, 3, 4, 5, 6, 7 can be inserted in an empty binary search tree such that the resulting tree height 6 is dash. Note the height of a node 0. Okay. There are given 7 elements. So height must be 6. Okay. Mm, one, height is 6. So in this way, you can imagine 1. This is left skew. We can also move it into right skew, right? Okay, right skew. Okay, equals to 1. We can this cross like this and then just is it catalog number? No, right. Yeah, it is such node is fixed. Next node have two choices. Either it can go so this can be like two choices. Depending on how to it can be like 2 or 6 choices. That's it, friends. 64, right? Okay, it will go like this and like this. We go like this. The national must be. Yes. Okay, we do not hold the last one because the last one must be to. First one can be. I mean, first edge can be either this or either this. Either this or either this. Either this. Okay. Okay, I got only 8. So let us say like 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This is okay. This can be right or left. Oh, okay. He's not in an explanation room. Okay, I have to move. Two choices, two choices. But again, 64 to power 6 is 64. 64. Mm. And oh, that's, a program takes as input balance to balance the stream. Cool. Just this. Okay. A program takes as input a balanced binary search tree with n leaf nodes and computes the value of function g of x. For each node x, the cost of the computation g of x is minimum of number of leaf nodes in left subtree or number of leaf nodes in right subtree. Okay, then the worst time complete subject program is okay. In binary search tree, okay, that's suppose this will be the binary search tree. So then search tree. Okay. Minimum. So the cost of computation, okay, and leaf nodes, okay, and leaf nodes, okay. Leaf nodes and value of function g of x for each node in x. Okay. Now the function compute and computes the value of function of the x. 50 minimum of f sub 2 right sub 2. Is it any in suppose to this function states station back. I think balance is it's okay. If we go by this, what minimum of different. Okay, then I carry back. Suppose if the tree is like with your bottom, if you go like this, is minimum of this two, minimum of this two, minimum of this one. We take only minimum, but we are not multiplying. And I think the should are careful. Also, this right, and leaf nodes and complexity of distribution. Number of leaf nodes in left subtree of x and number of leaf nodes of right subtree of x. Think, yeah, I'm not sure about it, but okay. Yes, yes. Marriage tree stores the value of range 37 to 537. Consider the following sequence of keys. Binary 81, okay. Consider the following sequence of keys, okay. Suppose the BST has been unsuccessful search for key 273. Okay. We're searching 273. Each of the above statement is not in order which we could have encountered them in research. Suppose BST has unsuccessful search. Okay. Which are the following above CPS list nodes in the order in which could have encountered this 73. Okay. So first case to some relevant to sound key. Which are the following above sequences the which we could have encountered them in such could have encountered to sound very encounter. 73. Option 2 and what is our next resume increasing and increasing. This test I will be getting okay. Let's finish this to 4%. That street T contains distant elements of the template of picking element T that is smaller than maximum element in T. So by such T contains all the state. Okay. It's the element of picking an element T that is smaller than maximum. So it is log n right? Smaller than something. That's why it's still. So, still. You are given a portion of traversal P. If a parallel search tree on elements N, you are given a portion of traversal P of a binary search tree given to N, and you had determined the unique binary search tree that has P as its post order of the range. I don't think doing this. Okay. What's a search tree? So, mm, if you P as a first of it was a good distance. The most efficient was most of it was a post terminus. I wanted how three, I mean, three was image of efficient unique one such tree. Efficient was true. And I think analogous or n I think. Yeah. So, what is the which of the following is tightest per bond? Which tightest means weak omega. Okay. Less than tightest means okay. Yeah. No, less than okay. It's weak omega. It represents the incomplexity when exerting an object from binary search tree. Notes. Okay, and notes it is if we want to insert is the leaf, we have to travel along that leaf. So I think it's less than again. Suppose we have balance in binary. Watch this system. Then, suppose we have balances as tree. Only n numbers we are given two numbers L and H out of and for a we have okay, so suppose we have balanced binary search tree holds n numbers. We are given two numbers L and H and wish to sum up all the numbers in T. What is skip and when you search when searching for a key value 60 minus search tree nodes containing the values 10, 10, 20, 40 to 70 are travels and not travels of not necessarily in the given okay files. How many different orders are possible which these values can occur on the search path from the root to node containing the value 60. They give me key value 60 minutes. Travels. The river travels. Not necessarily we can work with. different order quality that can key which will can appear on such person or root node containing the value 60. Okay, now you want the same is there is 60. The root was 60. Nothing about 10. Yes, just access all long question. Because root node, so from root to the node containing value 60. Okay, they ask me the value contains 60. So, what we can do just 1, 2, 3, 4, 5, 6, 7, 8. It's not 8. Is it date? I think so. No, not to date, right? Just trying to process. Oh, let Tn be the number of let Tn be the number of different binary substrates and distinct elements. Then Tfn equals to okay, where x is 2. Tn be the number of different binary search trees on n distinct elements. To n distinct. Then T of n equals to summation of n equals to of different binary search trees. What this is compute stores and what are the worst case complexities for insertion and deletion of key in such tree? Mm, out of it. It how to travel within a node of login and insertion and order communication. Okay, insertion like we can say and deletion both are in right deletion and login and login provides or okay, so then why negligible. The number 1 to 3 and settled by three such tree is some order, okay. The resultant tree, the right subtree, in the resulting tree, the right subtree of the root contains p nodes. Then let us imagine introduce this one tree. Right subtree contains p nodes, okay. The first number be the inserted tree must be okay, right? Like first number p minus 1, right? You minus 1 no, there are n nodes. There is n nodes minus p minus 1, okay. N minus p plus 1, no, it's minus 1. No. Suppose there are then the value should be n minus p plus 1. It should not be present. P plus p. Then okay, so right subtree of the root to the p nodes. First number to be inserted in the tree must be so the first number must be so the worst after 10 minutes. The worst case of running time. The worst case running time to the search for an element in a balanced binary search tree n power 2 for n elements is the given entanglements, generally given entanglements, but here they are 2 for n, then use the answer. Think plug and okay, if it takes cancel again the again plus n. I think the order will be n n. Suppose binary tree with 10th decimal is a complete binary tree. Okay, complete means okay. It should follow the order. That's all. Tree is sorted using array representation of binary heap. This what the heap concept of binary heap trees. Assume that the array indicates with 0. Okay, and the third largest element, the tree is sorted at. Okay, third largest element 0. Third largest element. Suppose assume that the array starts with 0 and the third largest element is sorted. Sorted means what? Suppose the binary search tree with okay, sorted means index, not index like third largest. 2000 minus 2 is 100 no, what the heck? 1000 minus 2 means 998. So if not wrong, this will be the answer. Index from because there are 10 elements, there carry index from 9. If you want to get the largest, go 9, ninth index, 8th index, 7th index. And it was 7th index. So here the index up to 0 to triple nine. Where is largest? Triple nine is 7, triple nine is triple nine 7. Minimum will be answer. 7. Data structure is required. The data structure is required for sorting a set of integers such that each of the following operations can be done out of log and n, where n is the number of elements in the set. Okay. Addition is smallest okay. Insertion of an element if it is not already present in the set. Addition smallest can be leftmost, right? Saying sorted and full of mine. Deep can be used but not balanced binary. Balanced can be used not heap. Okay, if you want to use heap, if you want to okay, heap there are conditions, right? Shortest means first of all root can be easily determined with this order. Okay, it's not heap. I think it is balanced remains, but P will be the answer. Okay, and B. Yes, we did the question, but let's see, like we have first time I know one. There are no negative marks for these questions so let me explore. Binary search tree BHT stores the value range. Okay. Okay. So suppose the value of balance. Suppose we have balanced binary tree. I think we have to submit tests. Suppose there is m such in the host performance. Highest means what? Highest means we can consider, we can ignore, there's anything wrong, right? A or B or D or C. So I think we submit it. Let me wait for this. I think and we get bare minimum. Oh, I got 40%. Six questions correct, six questions wrong, three questions skipped. It's fine. So which question is it? Okay, it's 64. Okay, yeah, and this question is 35. See what questions should I make correct? Okay, option yeah, B. So we were given a post-graduate traversal, three traversal, and three. Mean we have to travel. Post-graduate we have to travel around. Pre-travels we have to travel. Anything we have to travel, but post-graduate we have to travel 3 times. In 3 into n, it will become just n. Okay, and then question 110. Let's see the answer. Option B wrong. Correct answer is A. Okay, put up text. Let us see next. Question correct answer is B. Okay, that okay. Okay, correct answer is what 509. What they're saying 509. How in that 509? Saying so that let's see next. Okay. In this point, interest. Okay. The three can be sorted by because no, I don't know. Okay, fine. Question semi but this question also on the pre-order. Okay, that just go fucking answers B and answers C. Answers B, but the answers B. Good. The answers transit speed contains and statements. Suppose they think of the picking an element in T that is smaller than the maximum element in T. Okay, maximum element. Picking, okay, come on. T that is smaller than maximum. अरे यार picking it is just constant time, right? Okay. Let us start with this question. Nice question. Hmm. Oh, read question properly. Okay, we want node which is smaller than the maximum element. So left shell is always smaller than maximum code. I'm not asking about so what you saying. I'm not asking about the element being smaller than maximum. Level you can compare. So in case one root has both left and right side, has left child smaller root than you are right. Actually, I consider some general BST which has left and right child. You need to consider one comparison to order of n. Okay, the given constant and suppose I have BST on the root S1. I will never have left child, but comparing the root child doesn't matter left or right. Element that is smaller maximum or constant. Best case one root has both left and right child as left child smaller than the root before in just two comparisons. Yeah, it's just like constant. Right? We pick a smaller number than maximum element. This is constant hypothesis. This true root has screwed left. Oh, I'm alive. Yes. Okay, three root has skewed right tree. Okay, as we only go on right comparison root with S, the right element will be the as root as min element. Maximum, maximum, maximum. So it is caution. Okay, check random. Okay, it's giving me perfect. Oh, question, super question. So what is the best answer they have given? Oh, Deepak Punia sir has given best answer. If our data structure can adjust elements, then in all the standard data structure that we know or study about it, if you want to find any element that is not minimum, maybe not maximum, smaller than maximum, then time complexity will be order form because we only need to compare any two elements. Take any two elements that actually constant time, compare them and return smaller. Okay, yes, particular PS. And by standard data structure that we know study about mainly following minus stability, sorted, unsorted, array, linked list, array, stack, with hash tables, etc. Note we don't need to find the second largest element. We need any number which is not largest. So give us two elements, two elements and the smaller, and then your answer will be what type is equal. Okay. So, by the way, what is time goes if we do the elements on the load? Yeah, go with the elements on the load. Like, rest case, the BST will be skewed. So, often in the best it will be one. If I'm not correct, is go in step. Why why we are not considering the time which need for searching maximum number. Okay, yeah, it's a good question. Because we don't need to find the number, we don't need to find the maximum element, not maximum element. Means any element other than the maximum. Okay, so just find any two elements and smaller than between those two numbers. Here the confusion is either should we take the time complexity and finding the maximum element and also into consideration? In such doubts, read the question again. In all get PYQ, the answer is always whatever is asked. Okay. Time complexity of picking an element in T. Time complexity of picking an element in T that is smaller than maximum of the time complexity. Here we just need to find the time complexity of picking an element. That this question is, I mean, that is the question simply. Now what to pick? Getting a small element, hence either question without it, fail to find a maximum which is justified. It, it does not smallest at any small element thanks to presence. A type it, we don't need to find the smallest element. The small sign waste with duplicate keys. I'm just curious to find the question. Please correct me if I'm wrong. Okay. Mm, the question would have been like for a BST where some elements are not distinct. Okay. Then to find the smallest, okay, please make a question. The smallest element such that it is smaller than the maximum element would be our for H plus one, right? How H plus log, I mean, two H's. Right, to find the minimum element log H, then find the maximum log H, time would be then constant time to compare them. For example, I'm just curious to find something based with the question is okay. Okay. The height of the base VST can be n minus 1 at worst case. So find the maximum length out of that, right? Okay. Height of the minus H will be n minus 1. Actually, yeah, so clear strong. Like the maximum elements are defined. Here to find the maximum elements in the tree, it will take out of log n. Since we only traverse the right subtree, find the smallest. Okay, out of log n, not n. Because it's only okay. We don't need to find the second largest number. We need any number which is not mentioned. So take any 12 months follow the first will be okay. No? So here to find max element, tree will be taking order functions. It will only traverse head subtree and to find this small then max take order of one will take also therefore it will be well how they need to order first is my mission here to find the maximum element the tree it will take order functions we will not so we'll take order mission correct no you don't need to find maximum okay, right answers the way what the time to do it then the worst case the VST will be skew. Okay, for two messages it will be answered. Was for the is skewed. Small. If you have like that, it will have to go to in. Yeah, like in worst case, all for the best. Okay. Suppose they're given this is the more more and this is the largest value. And this entire thing will be this is the largest. Right, so if you will 11, the other thing will be 14, 15 like that. Okay, and here will be 14. Okay. Little bit, right? It's try to take, yeah, I mean, it's like, okay, speed already, and yeah, correctly upload this. Okay, fine. Here answer is T. Okay, okay, I got the answer. Yeah, it's good. Mm, this is so I got. Okay, let us do it again. A bias which tree contains and distinct elements. What is the time complexity of picking an element in T that is smaller than the maximum element in T? Let wait. A parallel such tree. Okay, T. Okay, T is a binary such tree contains and distinct. Okay, contains. Okay. I mean distinct, not duplicate. If they given duplicate means if they mention worst, I mean worst and good would be like order of n. I mean not what it is theta of n. In best case it would be one. I mean constant time. I think distinction is okay. What is called picking an element? What is the time complexity of picking an element in T that is smaller than the maximum element in T? Okay, what is time complex of okay? They are asking of the time picking an element in T. We need to find what is time. Okay, and those to be out of fine. I got the answer. And okay, that's what is the worst case time complex in setting and deleting a key in biosecurity. Okay. Worst case it will be at leaf, right? If you want to delete at leaf, it has to traverse to the leaf. And it, and the delete also both are same. So why you actually login? So they're not asking about max or min. Maybe like I think let us see this question. This question is quite good. This question. Skew tree. Yeah. Mm. Damn it. Tree. The brick. Oh, will take like for 5 minutes. Break down. Break. Okay, I'm back. Yeah. So here my mistake is in worst case, when such tree. It is cute. It is possible it is cute. So it needs to travel entire tree. So out of 10 is the worst case type. Got it. Yes. If it is mm, like in best case it can be in best case it can be login, right? Login. Okay. Cute. Okay. Nice. That's first. So yes, cute. Well, big connotation is also here. Not confused. Okay, let us see. Comment. When such tree is not high balanced tree. So it will have squirrel rate skewed. So it just written become fun. So true to explain that of being with the so the intention of constraint such organization. The average case is this such as okay. Worst case is this, but yeah, I got it. No drawbacks of good works. What it provided drawbacks. The last time I checked the worst case was because it's not big data. Even though you don't remove the note of any worst case. Okay, I think so that's kinds of nice. Make upload the description get answers. Vehicles. These answers. And control extra mark. Okay, fine. So where such here I need to take a point where so this where such tree is not a height balanced tree. Whereas ABL tree is height balanced tree. Okay. So yeah, let's take a shot of this. Okay, testing where scan on I think maybe window only window. So open up. I don't need to scan the text and take this. Okay, okay. Copy notebook. Oh, sorry. This get into this. Yeah, wishing I need to do this. Okay, fine. Text the plan. So that will like this. Okay, fine. And sell. This two first is no worst case. Worst case. Very good. Worst case is cute. Shit, if consider the worst case structure, okay. Worst case is cute. Okay. Nice question. Nice answer. And then okay, let us say which of the following is least nice, tightest upper bound in a life? Yes, like so, so and yeah, okay. Which of the following is the tightest upper bound that represent the time complexity of inserting an object into binary search tree of n nodes? Upper bound. So what? The binary search tree. Okay. Like it is big which they are given. Time complexity is not cross that forward. Then session. And definitely it will be login. Why? Because binary search tree is not high binary search tree, as we have seen like from here from this bro which he will is good. Yes. So the first time we can take like skew, like right skew or left skew. If you take that, like the minus HT will not cross that, so it is upper bound. It is log of n. Okay, fine. This log n is average case. Yeah. Okay, so the option is option C. That's good. So okay, let's discuss this question. This question, how this one? Yeah, give me any tricks. Manage such tree contains only features located on 46,000 words. We solve this question. Okay. Mm, yes, pre-order the given 3, 2, okay, 5. So left is 1, 2, 3, 4. Okay, right is this. And we consider these two given, okay, what? Pre-order root left, right. So I got it. What is the minimum? What is the previous comments? Okay. Okay, let's see. Pre-order root left, right. Given fair. The options are what? Okay, that's fair. So left is be 3124. But, pre-order towers. Okay, it may contain also stated we contain 3. Where is the root? If we want to print root, then it is not possible. Pre-order again, first thing is root of the 5. Okay, that is considered. Mm, so first of all, let us see. Let's see best of note pre-order means root left right there. That's okay. By option elimination, B is false because 5 is root not in pre-order sequence. First 5 then must contain 1 to 5. Okay. Yeah, I did the same. 6 comes here, so false. So now common things in option A and I mean common things in option A, C, D. Here 5 3 means 5 is root. Okay. So means 5 3 is 5 is root and 3 is 5 comma 3 means 5 is root and left subtree is LHS subtree root is 3. What? LHS subtree root is 3. Oh, Yes, it's true. Riches is one to. Yes, so they should come first rather than four. Okay, so option C is false. Now check with option D. Root 5 RHS. Root 5 RHS. The option is, I mean, RHS 6, comma 7. Now, as per the option D, A, comma D, uh, A, comma D, 7 is the root. So 6 must be left and 8 should be right. So clear out for me. Kirama and big. Nice. Mm. So we have to eliminate the options. Common things also too. Okay. Okay. Eliminate option A by not just like 1, 2. Okay. And option C will become 1, 2. And here we get you 2, 4. Okay. Option C is wrong. It's wrong. After 1, 2, 2 is okay. 2 is okay. And then after it should be okay, 1 to 4 should be right. So okay, should become this all should be right. Or should be right. Okay, okay. In this left tree, then okay, I got the answer actually perfectly. I don't think I got the idea. Diagonal 5 is 0. Because pre-order means root RT left comma right. Okay, go. So the root left subtree should definitely 1, 2, 3, 4. It's less than 5, it's greater than 5. The right subtree, right subtree will be 6, comma 7. Okay, the order might differ. I mean, total is also okay. 6, comma 7, comma 8. Comma 1, minus 2. Okay, nice. And if you consider the order, then 3 is also the root. Okay, first. Okay, if we consider this inner order, okay, the given 3 also root. Okay, 3 is root. And below 3, if root means then 1, 2 should be left and 4 should be right. Consider this and it will be like 1 is the root and then 2 will become here. That's all. So this is order like it will what there and then pre-order means root left right root left right. So to visit root it will go to left. Okay. All right. Okay, so if I remember pre-order means great. So if we want to traverse the tree from pre-order, post-order, and in order, so for pre-order, if you visit the node for first time, it is pre-order. If you visit the node second time, it is in order. If you visit the node for third time, it is post-order. Okay, I have remembered in this way. So we find mhm, left subtree and then right subtree. Root left right, root left right. Okay, root not root, root is subtree right. To left subtree and then again it will become root. Root left subtree again right. So root. Okay, okay, then fine, and it is now right subtree. Fine. And if we mention like There is no such terms will become between 1 to 5. It should be then okay, okay. The last two terms should be 6 and 7 only. It's not possible terms. 6 and 7. Okay, 6 comes sometime. Last terms is reserved for 6, 7, 8. Okay, 6, 7, 8. Option. Okay. Anyway, the option C is one. We have to check option A, B, and D. In option A, we check the last four terms. Okay, option A is okay. Option option B is slightly false here. But you can see after 6 there is between 4. Okay, option C is false, and option D is also okay. Okay, fine. So we have to consider option A and option D. If we consider option A and option D, if we see uh, what they were given, this is they have given 7. Okay, if we consider the root as 7, okay, consider root as 7, the left must be the less value, so it should be 6 and it should be 8. 7 should be 6. So option A is wrong, option D is correct. The way we have to find root left right, root left right. Okay, perfect. Yeah, I got idea how to do this. Okay, here's correct. Next question. What's question? The worst case running time for searching an element in a balanced binary search is n power 2 kernel. Okay, okay, this is balanced tree. Okay, they have given the time complexity also. Okay, okay, that's they have given elements. So we know how to do the balance. So you just have to find balance binary tree. What the worst case of searching? Okay, should be either this or this. Okay, we have to consider this or this. So it will be take both. What I have done is login. I have written login. I see how will be the answer. So guys, we can get CSE. I give Shilpa. Mm, Note to self. Please read the question carefully. I have now lost the count of number of times I have read BBST as only BST. Okay. Balance basically. Okay. For MSQs, both order of n, order of n for MSQ. That's true. So yeah, I have read the same n log n. So with n power 2, n is 2 power n. Balance the mandatory takes log n. Yeah, it's true. For n elements in worst case, so with n power n elements, worst case time will be like order of, I mean theta log n. Like log n will be unsubstituted. It can be weight or height balance. There can be anything like I think a height balance is only which area. More complexity of our I think weight balance is not in our syllabus. Okay, there was explanation. Okay, send me the explanation I got. Okay, fine. Mhm. Okay, yeah. This is what I done. Okay, yeah. If there is, yes, I will write the answer. If it is not balanced, then the answer would be uh, go off. But all right, okay, let me comment it out. Like, so if it is not dot section, it is not given as balance the balance. If it is not balanced balance tree is mentioned, then if it is mentioned like no, if it mentioned like if it is mentioned like balanced search tree. Okay, if it is like balanced search tree, mentioned like balanced search tree, then answer 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 would be like answer would be of no like order of n to with the power n, right? Power n, right. Correct me if I wrong. Tag and correct. Okay, let me mention like tag and correct. Okay, yeah. Here, right. Okay, here. Tag and correct me. So, it's not waste space. Okay, fine. If it is like managed, make it bold. Okay, because we have to comment. Then the comment is not like, okay, fine. Okay, worst case managed search tree. Path Raj both worst case managed search tree is not of login to login. What worst case managed search tree? And this is not. This is not good. I have devoted flag. Oh, okay, let me only about all of for balance tree. It should BST for balance binary search tree equals to BST search plus balance. Okay, then like there must be search and going to move the board and it must be balanced. Okay, fine. Hmm. Yeah, I got the answers same. Okay, I need to check this out. So it got okay. Hope this timestamp helps you. Timestamp. Say what comes. The first number with the string must be. What does it exactly means? According to the answer given above, you are giving count of nodes in the left subtree. This count of right, right. That means first number. Okay. Go with options unless could mix up. Okay. Try to it is try to various species with options. But in case if you understand logic behind it and concept, go with standard source. Root is always the functional to be inserted, and to find root node, we are counting the total nodes present in left subtree and right subtree. Okay, let's try to simple example like n equals 6, p equals 6, 1, 2, 3, 4, 6 are inserted. Right subtree will have two numbers and left. So now first number inserted should be 4. So and 4 equals to minus 2 and equals to option C. Let me see what's the best answer there. Distance option C. Okay, let us share elements. Number of elements in depends on X. Some number will be oh RST is not it's not belongs to RST. Okay. Element P element given P elements. Okay. Remaining elements for subtree is equals to n minus P plus 1. Okay, n minus P. So remaining elements for the LST is n minus P plus 1. Okay, remaining elements for n minus P plus. Okay, so LST root element n minus P. Okay, and this element root element n minus P. Okay. So, remaining elements for LST minus. Okay, these are remaining elements minus P plus 1. If we remove the 1, then it would be right. Okay, this, if it is even answer, then so I could upward and let's erase this together. This literally is so let's try n equals 6. Okay, P equals to 2. Okay, one function settled. Right subtree we have two numbers 5 and now so now find the number inside should be 4. One, two, and binary search tree in some order. Okay. The resulting tree, the right subtree of the root contains p nodes. Okay, p nodes represent the first number to be inserted in the tree must be first number which is root node, right? Yeah. And so total n nodes n minus p plus 1. If we calculate that, it will become left subtree total elements. So we just minus n minus p plus 1. We just minus n minus p plus 1. What she's saying? Try a simple example like n equals 6 p equals to 3. Let's p here. P means okay. P equals to p equals to 2. Okay. So so the left subtree let's do okay. So the n equals to 6 and p equals to 2. Okay. So given so let's imagine it would be like 4 could be 7 to 2, right? 2 means 5 comma 6. And the right should be 1, 2, 3, 4. 4. 1, 2, 3. Right. So if we want to get this element, can go. These are two elements, right? Total 6 elements. If we 6 minus 2, 6 minus 2, it will be 4. And if we minus 1, then it will be 3. Should be 3 elements, and 6 is the fourth element. Minus 2, 4, and minus p. It's okay, like by options we can go, right? So by options can go. So if we want to insert first element, it's p. P means 2. By 2. It's not 2. No, it's wrong. And p plus 1. P plus 1 means 3. What is not 3? N minus P. What is that? 6 minus P means 4. Yeah, it is true. Okay. It looks okay. This is both the methods are good. Okay, fine. Just both question. And I have to. Okay, okay, okay. And here comes the beast question. Oh, how to do this, man? I spend more over 3 minutes of my time on my level. Yes, I may option up to 1 hour. The next addition up to, let us see. I come to this completion. So let's see. How they keep regular binary search tree stores values in the range of 37 to 573. Consider the following sequence of keys: 81, 537. Such tree stores values in the range of 37 to 573. Consider the following sequence of keys. Okay. Suppose the binary search tree been unsuccessfully searching for key. Okay. Which are the famous sequences list in the order in which it would have encountered them in the search. Mm, okay, this question is there was no normal difficulty when you search tree. Normal difficulty. So then just read the comments. what we have found valid sequence or invalid sequence include confusion and conflict. Suppose unsuccessfully searched for key towards okay, such as towards which of the above sequence list notes in order in which it could have encountered them in the search. Okay, okay, so we are going in an order. We didn't find that key. So what are the cases that we didn't find that key? We have to search that. When we found valid sequence, okay. Yeah, it's true. Valid sequence. Although many questions use the correct terms, although many questions, the many questions, I mean, not what questions, what I'm reading is many people are there, not many questions are there over my mind. Although many people have given correct answer, but just mentioning another approach to solve this problem differently. Break the list and 2% verify. Okay, I have to explain one shortcut method is to type of example as less than 273 or 149 to 70 must be ascending order. Okay, and it is making some sense. And greater elements are 550. I mean, great 550, 57, 37, 465. That must be ascending order. So option is correct. This may not be right approach because in descending order it should be 50 and but it is not the case. So approach, yeah. I think his explanation is explaining options for greater than 270 elements of order. That's why it's varied in descending order, not possible sequence. Let us see the space stops. Okay, let us see the comments useful answer. Okay, the attacker. No need to go from 279 to 2 as less than 2. I should want to go from uh, using comps and get like we no need to go from above. Okay. Then again the guy was saying PC guy. If not, so no need to go from 200 less than 285. Option for running to go from 395 to 365 is as Naive, please explain, elaborate why option 3 is correct. Response no, no need to go on that. I mean, okay, let us find the best answer. Okay. Which all the above sequence list nodes in the order which we could have encountered them in such sequence 1 81 573 102 2 102 439 274 300 sequence ones we need to go from 285 to 376. we no need to go from 378 to lesson. Okay, from sequence to oh, we'll explain. Suppose the BST has unsuccessful search for key 273. It is like saying if we had been 273 in the actual sequence, then which of the following searches would be unsuccessful? Actually, if it is there been 273, then actual sequence that which following sequence is that's the opposite correct. Question is correct. Question. Let's try this question. Let me try this question. I get time up with me practicing. Hmm. Demanding at least 2 hours of like It's not okay. English madness. It's not a miracle mark about. It's cool. Ah, yeah. So kept my marker here in this bottle. And I'm searching for it. Nice. Okay. So let's be back. Well, what they guys? So just for instance, what did they say? What did they say? Like if you travel, pre-order, post-order, and checks all वगैरह stuff. I think it was complicated. Star 81, and then it is greater 537, and 102. It is lesser 102. Okay. Star 81, everything should be. It is greater means everything should be less. Okay, 102. Then after 439. So after everything should be greater than everything. Greater than, okay, fine. Everything should be greater than 537. 5 multiplied, okay. 297 should be greater than, okay. 142 greater than 550. Great. No, everything should be less than. Option D is straight away false. If we consider like, okay, why option D is straight away false? How did they make the conclusion? Means, oh, this is 550. Okay, it is a root node. 144 is, I mean, 140. Oh, no, 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 no. 550. Okay, there is no such element called. Okay. So let us say if there is sequence called 550 and 149 and then 551. No, this is wrong. The sequence is straight false. See 149 and like it can place here 551. But here, if we consider the upper root node, then this left subtree should be always less than 550. Okay. And here, if we see 551, so this is straight away false. Not obtaining, not pure. Okay. How? I think we need to draw 539 and 285. Not next, 285. Okay, 285. Then 376. 376. Okay, like 376. Even here we skip, right? Okay, option A is false. Why? Because 273 can be here. It can be here, but they are crossing and they went. Okay, fine. It is false. That means 752. Then 97. Then 121. And then 195. Then 242. Okay, okay. Here it should be 273. But here they are given. Yes, it's still false. Oh, wait. It can also, right? 381. Here it can be 271. But the cross in the area 472. Where there is no scope of this. I think consider third option 142, 248, 248 after 520, 520 after 386, 386, 386. So 345, 345. Yes, sir, 345. Okay. 270, 270. Oh, no, 270. Yeah, no, 3 is not 70, not 7. So yeah, here is one possibility. Option 3 is correct. I mean, only 3. Okay, there you go, 4 plus 2. Take so much time. Is there any shortcut to 540, 49, 49, then 507, then 395, 463, 402, 270. Okay, they cross it. They have crossed it. Okay. So yeah, so can we range 37 to okay. So the last two rings must be 273. Like they need to near 273. If the third option, like if they have arranged 270 greater, yeah, if they were arranged 307. Okay, okay, you know, there is here option, but here can be 273. It is true. Okay, see this sort of. Mhm. Yeah, it might be encounter. So because it might be encounter to be left of 307. Nice question. You see, I think state one more. And star question. Oh, no, this question. Maybe we can also see. Okay, this question. This question. Okay. But in data structure is required for starting a set of integers such that each of the following operations can be done in out of login. Wherein is the number of inventions that English is smallest number of small segment, it needs to go to one more side. I mean, only left subtree, it needs to travel towards the left subtree, and it will take a login time. And insertion of an element, if it is not already present in the set. Okay, insert of it, like it will take a leaf nodes. It will also take out of login. I mean, if it is not skewed, it is not skewed, then take out of login. What is okay? Okay, here what they're saying, okay, this is a problem, then can be balanced search. Okay, here balanced search and as well as ABL also, I think, yeah, ABL also possible. This question, let me point it out. Let's get real try, I think. This question, ABL is possible. Not 25. Balanced search. Okay, the balanced search strings this. No. This thing- That's it. Balance with binary search tree, right? So let us ask balance with binary. No, balance with search tree is not exclusive of any APL tree. Balance APL tree is specific self-balancing border category, glitching the structure. Okay, okay, fine. I think need to recorrect. Oh, if ABL is so no, like because balance search tree is it about when then solution. Suppose a balance search tree. Suppose a binary search tree with thousand distinct elements is also a complete binary tree. Complete means what? Complete means like here the order matters. Okay, like it should have to be filled. Okay. If you remember, I don't know. I think no one is watching this live. Okay, in live one, I told I have confusion between complete binary tree and full binary tree. Now I will get confused. I will get one clarity. Complete means here, like yeah, we have to fill the tree from left to right. Okay, called complete, and this is full. This is full binary tree. Each node should have at least zero or two. This is full node. Okay, full. I mean full. I mean full means full. Okay, and here mm, complete tree we should have to fill like this. Yeah, this is complete. If we can say, if we can fill like this, this is not either tree, it is not binary, it is not in it, it is not binary tree itself. It's, that's true. Okay, okay. This is what they have given. Okay, this is what they have given. Okay, and then the tree is sorted using the array definition. Okay, tree is sorted. Okay, in binary heap. Oh, binary heap. Assume that the array indicates start with zero. Okay, array is okay. He okay. Zero and you have to find the third largest sorted at index. Okay, if we have to see sorted, from the largest binary heap. I have come across this binary heap concept. Let me see how I written binary as the answer. So I have taken index in between 0 to 100. I just have removed from two elements, so it will be the largest, right? So I got the answer. Okay, let me check. Question is hard 9%. Yeah. There are 8 comments. So this question, okay, what heap can be used? 2 3 question. This is ISRO 9 question. Okay, okay, okay. They have revised this question. I mean, if I get it to ISRO, then I should ask helpful to this question. Okay, fine. And then if you know balance sheet, so before any of you are smart people start arguing what I am posting, I'm generally find out largest. Yeah, it's true. Like in largest, let's should I complete binary, then it is largest. First largest and second largest and largest. RDT2 use in order to find the nth largest element. But here the question is told that the array is sorted using binary heap tree. So it will be sorted like this. Yes, it's true. So, so what? So should I sorted like the root and then this is the second largest. So the second largest. Okay. Sorted in array using binary heap. One second, this is generator. Sir has explained nicely regarding this question. Keep in mind that we are talking about complete binary tree, which is left field. What? No, it is not left field. Like we are fielding from the left to right, not left field. Okay, so if we check the number of nodes, you have realized that last level is not completely filled, which means there is no element below last last element of second last level. Here, let's hope this hope this okay, hope this helps for the first one, right? Like log two it will be in line. So it will make sense. Saving for my reference. What is it? Why is it?
Let us try to solve the sanity based on binary search tree concept. हमसे बोल रहा है suppose a binary search tree with 1000 distinct element is also a complete binary tree. The tree is stored using the array representation of binary heap trees, assuming that the array index start from are there. ठीक है. If I want last level to be full, sir, 8 nodes ऐसी हो चुकी होंगी. Of course, even. ठीक है. And एक नोड रह गई होगी. तो जो एक्चुअल डायग्राम है वो कुछ ऐसा है. इज इट सो? जस्ट फोकस. इज इट सो? इज इट सो? जस्ट ट्राई टू फोकस कि ऐसा है या नहीं है, हमें समझना पड़ेगा बिकॉज ये बहुत ज्यादा इंपॉर्टेंट है हमारे लिए समझना कि ऊपर ऊपर 256 जो नोड हैं उनमें से 244 नोड्स ठीक है, ये दो दो चाइल्ड होंगे, ठीक है। उसके बाद जो नोड्स हैं उनका कोई भी चाइल्ड नहीं है, इसके बाद जो नोड्स हैं उनका कोई भी चाइल्ड नहीं है। ये इंपॉर्टेंट है समझने के लिए, ये बहुत ज्यादा इंपॉर्टेंट है समझने के लिए। दैट मीन्स हमारा जो ट्री है उसका डायग्राम कुछ ऐसा बन रहा है। तो व्हाट आई वांटेड टू कन्वे इज सेकंड लास्ट और लास्ट लेवल में आपको जरा दिखाना चाहता हूं। मान लीजिए ये पहली नोड है सेकंड लास्ट लेवल पर, ये दूसरी नोड है सेकंड लास्ट लेवल पर, ये बहुत सारी नोड्स हो गई, ये 244th नोड है, ये 245, 246, 247, ये इस तरीके की नोड है 256, ठीक है। हमने कहा कि भैया 244 नोड्स तो ये हो गई, इनके दो दो चाइल्ड हो गए और इसका एक चाइल्ड 245, समथिंग लाइक दिस, ठीक है। ऊपर की कहानी आप सबको पता है, ऊपर की कहानी क्या चल रही है ना, उससे हम कंसर्न्ड ही नहीं है, बट जब आप इसका इन ऑर्डर ट्रेवर्सल निकाल रहे होंगे, तब कहानी क्या आएगी ये इंपॉर्टेंट है, ये सबसे ज्यादा इंपॉर्टेंट है, ठीक है। दैट मीन्स जस्ट ट्राई टू फोकस कि एक्चुअली इसका डायग्राम कैसा होगा। इसका डायग्राम एक्चुअली कुछ ऐसा होगा। हमने कहा यहां पर नोट्स हैं, बिल्कुल हैं, ठीक है। ये सेकेंड लास्ट लेवल तक पूरा भरा हुआ है, सेकेंड लास्ट लेवल तक। जस्ट ट्राई टू फोकस, सेकेंड लास्ट लेवल है ये सेकेंड लास्ट लेवल है, ठीक है। सेकेंड लास्ट लेवल तक पूरा भरा हुआ है, क्योंकि लास्ट की 12 नोड्स सेकेंड लास्ट लेवल पर, लास्ट की 12 नोड तो खाली हैं। तो अगर मैं कहता हूं ये मेरी नोड ए है, ये मेरी नोड बी है, जस्ट ट्राई टू फोकस, ये खाली है ना, एम्प्टी, दिस इज एम्प्टी, दिस इज ऑल्सो एम्प्टी। जस्ट ट्राई टू फोकस, ये सेकेंड लास्ट लेवल है, ये सेकेंड लास्ट लेवल है। सर तो कहानी तो कुछ ऐसी होगी ना, जब आप इसका ये सेकेंड लास्ट लेवल है, दिस इज सेकेंड लास्ट लेवल, और ये है लास्ट लेवल। तो जब आप इस ट्री को ट्रेस कर रहे होगे, सर ए का कोई सब ट्री तो है नहीं, तो इसका इन ऑर्डर ट्रेवर्सल जब आप इसका इन ऑर्डर ट्रेवर्सल निकालेंगे, तो सबसे पहले कौन आएगा, ए, देन आएगी रूट नोड, देन आएगा बी। इन ऑर्डर ट्रेवर्सल में ए पहले आएगा। अरे इन ऑर्डर ट्रेवर्सल में ये कंफर्म है, लास्ट में देखिए इन ऑर्डर ट्रेवर्सल में पहले कौन आएगा, ए आएगा, देन रूट नोड आएगी एंड देन बी आएगा सबसे लास्ट में। लास्ट 3 नोड्स, बिल्कुल ठीक है, क्योंकि ये लास्ट 3 नोड हैं, दैट मींस ये हमारा लार्जेस्ट होगा, ये सेकंड लार्जेस्ट होगा, और ये हमारा थर्ड लार्जेस्ट होगा। दैट मीन्स थर्ड लार्जेस्ट एलिमेंट कहां पर होगा, आपको पता है, अच्छे से आपको पता है। थर्ड लार्जेस्ट एलिमेंट सेकेंड लास्ट लेवल की सेकेंड लास्ट नोड होगी। थर्ड लार्जेस्ट कहां पर है, सेकेंड लास्ट लेवल, ऑन सेकेंड लास्ट लेवल, सेकेंड लास्ट एलिमेंट। ओके, दैट मीन्स कैन आई से, बिकॉज ये 511वां एलिमेंट है, कैन आई से 510th एलिमेंट, 510वां एलिमेंट है। हाँ, बिकॉज इंडेक्स स्टार्टेड फ्रॉम जीरो, its index is 510 minus 1, 509. That's the correct answer. तो हमारा जो एलिमेंट है उसका इंडेक्स क्या निकला सर 509. हमसे यही क्वेश्चन में पूछा गया था कि इसका इंडेक्स क्या होगा. सो द इंडेक्स इज 509. बहुत ही अच्छा क्वेश्चन था. कि इसका इंडेक्स क्या 510 0
Set hundred notes, right? Like 1,000 notes. Set 1,000 notes. To power H notes. Because the field device is needed. The number of options will last or equals to. Um, research to that's the 10, right? 10. Okay, this is 10. And 5 will goes left and 5 goes. So if 5 goes and 6, 8 element, 8 element. One should be correct. The element is correct, but his starting index is 0. This 5 not 7. 5 is not extra. Well, some 8. What with the answers? Sign up 9. Still. Distance servers. We line distribution of the sales definition of computer energy. Complete management definition. Okay. But we will not penetrate instead of right circle. We get some plot disturb. What can we take it together? There is DS. DS data structure for GATE. Any present last level of right subtree. So depends, not always yes, not always no. Whether the last one has any node, you will write subtree. Depends on exactly how many nodes are in the clever root. I'll let the last level H as k nodes and let the high capacity to for H full level and k less than for H. If k less than for H by 2, then level almost full. So what I'm saying, still only yes, how 511, 511, then for right now, what is the default counting for levels? 0. Default is 0, conversion is constant 0. Why is using auto traverser? Because PHP not for it. I think it's a question where we can't get what solutions. Because we can do it's up there. Okay, this mm, now I think that is what is user? It's a smart it's a few smart start with start on the how to escape. What I'm posting is the general impression. Okay. That's power. It's just almost same how train trying to again. Hope this was no not the way you look at the last friend height. Okay, height is 9. Take crystal. Take height is 9. So last okay. So it's as a 10 hours, 93 watts. Last one is to 512, 512 minus 20. Wait, 512. So the answer will be so keep in mind the time reciprocity which is left field. Just must realize that we always not completely replace this one with the last time. With that, what does it say? It is saying false. Okay, it's just password. Accept it. Accept it. Doesn't mean um, accept right. Means it follows. Just to follow that field and it's left to do correct with the handwritten or solution. I hope, okay, below in the handwritten solution, I hope to be able to find the handwritten notes. Create such and such. We are given 1,000 distinct notes. Okay, let me. She's definitely not to one more question. Here we have 1,000 distinct notes. I use height of complete boundary trees to purchase minus one edge to egg or h equals to n log n. Here we'll get height as here with considering height. We are considering height as the upper boundary. I can even but we are okay. Because Roman height starts from 0. Fine. From 1,000 elements, h equals 9 to 491. 1023. There are total fields of 1023. So whereas we have only 1,000 elements, since we have only 1,000 elements, so it will be not perfect binary tree. That is not completely filled. Level 0, level 1, level 7, level 8. So we have to find these two elements and this node. This will be the second largest because there is only else present only. Okay, only level 9 will be coming. Okay, these two nodes will not have any challenge because we have less nodes. If we would have 1023 or 1022 or 1021 or 1020, there two children would have a challenge. This will be our third largest node, which has no children. Since given VST is sorted like heap and largest element, index is 510, easily can be derived. Largest element before largest major to power to power 8 plus 1 minus 1 minus 1. Oh, so frequency plus sorry to 9 into 1 try to master. So example, yield can be example I equals to index on the largest to the different from the option. When the second largest sequence, so three method. Find the second largest index, use heap sorting property. Largest node, largest node equals 510. If our index starts from 1, it will be 511. So its parent is 11 by 2, 55. To convert back to the, we can share the index from 0 to 54. Find the second largest index. Okay. Crazy expression, right? This president, yeah. Focus, let's first, first find the height. Height equals to 9. Yeah, why did it because I started from 0. It's at this equals 9. So we know that fill USB completely we need from 0 to 3 nodes. Okay, yes. So, and then but we are sort of from 0 to 3 dimensional to the when we are sort of 23 nodes. Okay. But actually, at the last level we have, okay, and actually last level we have 5, 12. Okay, why? Because we are, wait. The last leaf level is completely filled. Yes.